Okay, good morning all. So this is going to be the do now review for the day. So rewrite the given system of inequality with a system inequality in slope-intercept form. So we have 3x plus y is less than or equal to 6, which is in standard form. So what I need to do is when I rewrite this, I need to isolate the y variable. And I do that by subtracting 3x to both sides of the inequality. It lets my y variable by itself, which is now less than or equal to negative 3x plus 6. And then just take the other inequality and put it right below it. From there, I can now graph and identify a solution set of the inequality. So here, let me take the first one. I know that when we are looking at this, we need to identify the y-intercept, then the slope, and then the type of inequality. The y-intercept is 6, the slope is negative 3, the inequality is less than or equal to less than or equal to. Because the slope y-intercept is 6, we're going to plot the point 0, 6. 6 units above the origin on the y-axis. Slope is negative 3, which is in a fraction negative 3 over positive 1, which means we're going down 3, right 1. Down 3, right 1. Down 3, right 1. And we just keep it moving. Keep it moving. Keep it moving. Or we can go up 3, left 1. Either way, we have a solid line. Arrows at the end, in which we're going to shade solid line, because it's that equal part, it's inclusive, all points are included, and then shade below. Next up, let's use the other inequality. Y is greater than 3x minus 2. Again, what's our b value, m value, and the inequality? So our b value is negative 2, which is 0, negative 2. Our m value is 3, which is 3 over 1, so positive 3 over positive 1. So up 3, right 1. And our inequality is less than, just less than, so it's going to be a dotted line. Shade above. So plot the y-intercept at 0, negative 2. Up 3, right 1. Up 3, right 1. Up 3, right 1. Up 3, right 1. Or down 3, left 1. Down 3, left 1. Dashed line. Shade above. Therefore, the solution set is that double shaded region in these quadrants. All right. With that being said, is point 1, 1 in the solution set? Yes or no? 1, 1 is right here. Do a new color. It is on the line of the dotted line. So because it is on the dotted line, we have figured out that it is not in the solution set because it is not in the double shaded region. And again, although it's on the line, because it's a dotted line, a dashed line, it means that means it's not included to the points. It had to be solid for it to be. So now let's move on, everyone, to example 1, create systems of linear equations from word problems. This is when we put everything together as one. So Zanaya works for X hours after school at a job that pays $4 an hour. She has accepted another job that pays $8 an hour as a library assistant, working Y hours a week. She will work both jobs but is able to work no more than 15 hours a week. Zanaya wants to earn at least $80 a week, working both combination of jobs. So first thing first, I need to identify the X variable and the Y variable. Okay, so the X variable, it says right here, for X hours after school at a job. So we can say it is the number of hours of job number 1. And then here, Y is a library assistant working Y hours a week. So we can say number of hours of job number 2. All right. Moving on, we know that this X hours is going to be, this first job pays $4 an hour. So we write that as 4x. The second job pays $8 an hour. We can write that as 8x. 8y. Because it's the second job. The second job is the y variable, so 8y. She'll work both jobs. That means we're going to be adding. But is able to work no more than $15 hours a week. No more than 15 hours a week, meaning it's going to be less than or equal to 15 hours. So now it wants to earn at least $80 a week. That T term at least $80 a week, meaning it's going to be greater than or equal to $80. So what type of inequality are we going to come up with? Well, let's look at all resulting terms. Let's start with at least 80. This is $80. So we have to look at which of these deals with money. Well, we know we get paid $8, and we can know we get paid $4. Therefore, putting this all together, it's going to be 8y plus 4x, which is now greater than 80. Okay, as for 15 hours, which of these are hours? Well, one job is going to work a certain amount of hours, another job is working a certain amount of hours. And it's in our variables. X is the number of hours of job 1, y is the number of job 2. Therefore, x plus y is less than or equal to 15. Here is our system of inequality. Now we got to rewrite this to make it graphical, meaning we have to convert to slope intercept form. Okay, how do we make sure these systems are inequality graphical? Gotta make them in slope intercept. So let's start with the first. Let's start with the second inequality, real quick, real simple, because there's no coefficients. All we have to do is subtract x to both sides, just like we did for the do now. Y is less than or equal to negative x plus 15. There is our inequality. What was our first inverse operation? We subtracted our ax value on both sides. Okay, then let's go ahead and do the next one. 8y plus 4x greater than or equal to 80. What was our first thing again? Subtract. 8y plus 4x, yeah. So let's subtract 4x. 8y is greater than or equal to negative 4x plus 80. And then we're going to divide 8. We're going to divide that coefficient to both sides of the inequality. Negative 4 over 8x plus 80 over 8. Or if we were to simplify it, 1/2 x plus 10. So here, for us, the first step, we subtracted. And then we divided. And then here, we simplified. So what involvement is needed lastly? By dividing the b value on both sides. And so putting this all together as one inequality, we get y is less than or equal to negative x plus 15, and y is greater than or equal to negative 1/2 x plus 10. The key thing here, class, that I also want you all to get situated with, is that we're going to have these key phrases thrown at us throughout the year. More than, exceeds, and excess of, all this is going to reference to greater than. Inferior than or up to, less than. No more than or at most, less than or equal to. No less than or at least, greater than or equal to. Please copy the key phrases from the word problems as well as the work that you see here. All right. Please pause the video, make sure you have all the works as indicated in your notes, and then go ahead and move to problem set A. So now you have finished with problem set A, we're going to go on to problem set. We're going to example 2. We're now going to be graphing these inequalities. So again, we were in standard form. We convert a y-intercept, standard form, convert a y-intercept. Quickly put, our slope well, that is -1. Again, there's a secret, -1 being multiplied by x in this case. That coefficient is at -1, therefore our slope is -1. Our b value is 15, our inequality is less than or equal to. Meaning, when we do -1 in a fraction, -1 to a +1, meaning down 1, right 1. 15 is a point, 0, 15, and less than or equal to, meaning it's going to be a solid line. We're going to shade below. All right, so let's graph. Oh, but wait, our graph is too small. There's only 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So what we need to do is rewrite this graph to make sure it is graphable. So I just go by 2's then. This way, my point 0, 15 can be easily reached right here. And go down 1 to 14, and we do the same thing here. 2, 4, 6, 8, 10, 12, 16, 18. It's really good to make sure that the same key you have on the upside is the same on the right side, so it's all equal. So we go down 1 to 14, right 1 to 1. Down 1 to 13, right 1 to 2. And we keep it moving. Keep it moving. Okay, again, we're going all the way down up to this line, not further, not past. Reason why is because we can never have a negative. Again, x is hours, number of hours. Y is number of hours of job 2 and job 1, right? We can never have negative hours, right? Therefore, when we draw this line, it stops at these two endpoints. And as for a geometry term, these are called line. This is now called line segment. All right, and shade below. All right, now let's go ahead with the next one. Slope, -1/2, b 10, inequality greater than or equal to. Meaning we're going to go -1 over +2, down 1, right 2. B is 10, so 0, 10. And we're going to have a solid line, shade above. So 0, 10, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, 2, down 1, right 2, down 1, right 2, down 1, right 2. And draw that line. And shading above. All the way above. What we find here is that this solution set, right, this area is a double shaded region, which means is the amount of hours that Zanaya can work at both jobs, meaning she can work for the first job at 2 hours and the second job at 10, and this first job at 2 hours and the other job at 12, or 4 hours and the other job at 12, or any variations, like I think here would be like 3 and 11, or 1 and 13, right? And also because these lines are equal to, right, they're all inclusive, we can also say it is, what's a good one? What's a good one on this line? We can now also say we can not even work our first job at all and just, 15 hours at the second job. But we want to do both jobs, so maybe right here, where she works 5 hours at the first job, 10 hours at the other. All right. So putting this all together, the solution set determines the amount of hours she's able to work at both jobs, where she's working 80 hours a week, where she's working 15 hours a week for $80 a week as well. So here's a big stamp. Before graphing our solution set of a word problem, we convert the equation to slope-intercept form, then identify the slope, intercept, type of line, and direction of shading in the first quadrant. Again, the first quadrant, because we're only dealing with positive values, as this is a word problem. Please have this all in your notebook, as you shown here. And once you finish with that, please move ahead, pause the video, and go ahead and answer questions from problem set B. Thank you and have a great day.